In this video, we are going to use a sample JavaScript application to explore database and see how Metis can help optimizing the SQL queries. We are going to use Sequelize, which is a feature-rich ORM for JavaScript and TypeScript, and as a data source, we are going to use IMDb dataset, which stands for Internet Movie Database. It's available for free, so we can just download it and load into our PostgreSQL instance to play with it. What we can see on the screen now is the schema of the tables we are going to use throughout this video. The most important table is called Title Basics. This is the table that holds information about all the movies that we have in our database. Their title types, primary titles, start year, end year of production, runtime minutes, and other stuff. The important identifier is tconst, which stands for title identifier, that is used to join this table with other tables we see on the screen. We have a couple additional tables, for instance, title ratings, that holds the average rating as presented in IMDb, or title principles, the table that shows the people that actually participated in producing a movie. Similarly, we have a title crew that lists all the directors and writers for a given title. The other table, which is important, is called Name Basics. This table holds the information about various people that could be actors, directors, writers, and other stuff. When it comes to the relationships, you can see that one title basic can have one title rating or multiple title principals or one row indicating a title crew, but this row can have multiple directors and writers in it. And one title may have multiple names, multiple people, which goes the other way around as well. One person may be in multiple titles. So this is what we have in our data source. It is important to understand that this table, this database, is denormalized, meaning that some columns actually contain compound values. For instance, genres in Title Basics, it can hold a list of various genres associated with a given title. This can be especially important when it comes to directors and writers, because those are basically JSON lists of the people working on a given title. Let's see actually a couple of examples from the database. So I'll now open database visualizer and I'll get 10 rows from Title Basics. So you can see that each title can be like TV episode, like a short movie, like a full-length movie. It has original title, whether it's for adult audience and whatnot. And finally, we can see that this denormalized genres column holding multiple values. Similarly, we have Name Basics. Name Basics again is like a list of people with their primary names and profession and the list of titles they are known for. So again, we have a denormalized column. For title ratings, this is actually simple. We have just one row for each title with number of votes and the average rating calculated for given title. For title principles, again, we have people related to the titles, we have category of each person as it was working on a given title, and we have like a list of characters that person was starring. And finally, we have a title crew table that holds data like a list of directors and list of writers associated with a given title. So this is the data source we have. When it comes to the application we are working with, I have a very simple application written with Sequelize and JavaScript in which I defined a data model. So this is like a sample of the tables I'm using. You can see the table called Title Basic that holds the tconst identifier, so identifier of the title, some other columns as we specified and other things. And you can see those denormalized columns I'm storing basically as strings. So here genres is basically a string which will then process manually in the application. So this is what we have on the backend side. For the front end, I also have a very simple application that is basically a UI with various scenarios I'm going to use throughout this video to show how Metis can help. So let's start with a first scenario we would like to optimize, which is 10 latest movies actors has starred in. Once I click on that, you can see that the name of the person is already pre-selected, or maybe the identifier of the person, and the query is now running behind the scenes. And this project is already integrated with Metis. So let's see what's going on actually at this point. So I have the operation looking for titles for an actor, and I have a couple of implementations extracting the data, and we are going to run those queries, see what Metis shows, and we are going to optimize them one by one. So when it comes to the query that is now being executed, this is the application code that is triggered. So you can see that I'm taking title basics because we want to get titles for an actor. So I join title basics with title principal based on their relationship, so on the tconst identifier they are joined on, and I look for title principals for given nconst identifier that I got from the UI. Then I order all those results by the start year, so the production of the movie, and I take 10 latest movies to present for the result. So this is the application code that uses Sequelize to run the query. Let's see what's happening on the front end. And as you can see, this query is still executing. We have millions of rows in the database, and this takes time. So let's wait. Okay, as you can see, we have the data. It's only 2 movies that we did find out. Let's now see what Metis shows. So I integrated this application with Metis. If I now go to the project that I created behind the scenes, you can see it's empty. Let me refresh this page. And now you can see there is some recent activity showing that I code this endpoint titles for an actor. If I go here, you can see that yes, there was a query that executed and returned some data. Let's click on it and let's see what exactly happened. So you can see this query was executed. It took nearly 100 seconds to execute this query. You can see that it read 70 million rows and returned 2 rows and accessed 15 various columns. If we go to like the table summary, you can see all the tables that we accessed when executing this query. So you can see that we read nearly 70 million rows, or over 70 million rows in those 2 tables. One of them was title principals, where we read 60 million rows, and then title basics, where we read 10 million rows. So this is generally very big, and you can see it loaded lots of data. Let's see the SQL query statement that we executed. So when we go to SQL tab, you can see that for this application code that basically took title basics and joined them with title principals, we generated, or the Sequelize generated, the following SQL query that was sent to the database. So we can see that we are taking select some columns like title basic and title principals from, and there comes subquery, which is again selecting something from title basics, and where we use another subquery that takes title principals, does filtering based on the value we provided in the UI, then orders the rows, joins again with title principals, again does the filtering again, and finally returns the data. So we can definitely see this is something unexpected. Like, we wanted to just have one straightforward join, but what happened behind the scenes is we have like some nested queries with subqueries, and what's going on. The answer, what is going on, is because our application code did not specify how many rows are like connected between title basics and title principals, and how to deduplicate these rows. If we go to Sequelize documentation, we can see that there is the column, the option called duplicating, which mark the include as duplicating, which prevents a subquery from being used. So by default, the rows are supposed to duplicate, meaning that the Sequelize cannot just extract the data without handling these duplicates properly. So that's why it wants to use the subquery to get rid of the duplicates. However, if we say that, hey, there will be no duplicates in this data set, then we won't be using subquery as specified by the Sequelize documentation. Can we turn this flag, and meaning can we get rid of duplicates? The answer is yes, we can, because we get title principals based on the filter, and we know there will be exactly one row in given title principal with specified nconst for a particular tconst. So what we can do next is, instead of doing this basic code, we can use an application code that specifies that this query is not duplicating the result. So we can set duplicating to false. Let me now change the application code to use this other application. Let me restart the backend application, and then let me restart the query again. So you can see that I hit reload titles, and let's give it a second to complete. You can see that it finished already. If we now go to Metis, to recent activity, and refresh the page, you can see that now we have two calls to Sequelize. The old call that executed in 1 minute and the new call that executed in 5 seconds. When we open it up, you can see that we read 57 millions of rows instead of over 70 millions as before. And then when we go to SQL statement, you can see the query is now much more decent. It does not use the subqueries, it just does the join as we would expect. However, when we go to insights, we can see that we are still reading many rows, and this query is generally very slow. Can we improve it even more? Well, we can. We can notice that we scan title principals instead of using an index for that. So what we can do now is we can create an index and see whether it's going to help. So I have the code for creating the index, which creates the index on title principals table with nconst column and includes tconst column as well to make this index better. So let's run this query and wait for it to create this index. This may take a while because the index is built on the entire data set, which holds like millions of rows, as we can see. If you were to run this index creation in your production table, then you may need to plan ahead how to do that to avoid the outage of the database when you are actually doing this operation, in order to avoid like table rewriting to copy the data on the site and create it back. Okay, let's wait for this query to complete. Okay, we can see that index has been created. It took nearly 2.5 minutes to do that, so that definitely took some time. When running that in production, make sure you plan it ahead to avoid any issues and outages. So let us now go back to the application. Let's hit reload titles, and you can see that the result is now back. If we go to recent activity in Metis, you can see that this time this thingy executed in 24 milliseconds. When you go to this SQL, you can see the query statement is exactly the same, but this time we read only 4 rows, returned 2 of them, and 15 columns. So this is the first scenario that we optimized with Metis. As you can see, we identified a wrong query being sent to the database because of lack of duplicating flag, and then we identified a slow table scan, which we replaced with much better index read. Let us now carry on and move on to the second scenario we have. So the other scenario we have finds movies, common movies for 2 actors. So let me select this query, common movies for 2 actors, and let it run behind the scenes. And you can see this is the query that we executed. And what it does, it returns 1 movie that both actors start in. When we take a look at the application code, what happens is we take title basics and we join them with title principals twice to get the data. We filter first join based on first actor identifier, second join on the second actor identifier, and then return the data. Let us go to Metis and see what happened behind the scenes. So let's go to recent activity, let's refresh the page. and you can see that indeed we have our query in here, and you can see that is reading the rows like over 500 rows. This is the SQL statement that was executed. You can indeed see two joins being executed. And if you go to tables, then you can see that we scanned the principals index that we created when working on the previous query. So far, so good. The only problem we may have here is that when we go to the application code, we can see that we had to join title principal twice. And unfortunately, in Sequelize, in order to join one table with some other table twice, we need to specify two relations in the application code. So you can see when configuring the ORM, I had to say that, hey, title basics, they have many title principals. And then I had to repeat the same, that title basics have many title principals using different alias. So this is something that we may not necessarily like. So instead of configuring these aliases, which are purely a requirement of the Sequelize ORM, we may decide to implement this query in a different way. So what we can do is we can implement this query in application. Instead of doing this join, what we can do instead is we can get all the title principals for given actor, scan the title principals table again for the other actor, and then when both of these queries complete, then we scan title basics and look for the movies which have the tconst identifier in both of these collections. This is what we can do. So let's start this application, change the application code, and see how it's going to work behind the scenes. So I am now restarting the application. I am going back to the UI and hitting the reload button. And you can see it returned data. It returned only it slightly differently because we map it to some different columns, but still it is the same row. So if we now go to Metis, refresh the page, and go to the new query we executed, you can see that it executed for 50 milliseconds, so slightly longer than the previous one. And you can see both of the queries as executed, like as designed, as we implemented them in the code to get the title principals. And then the last query, which is getting title basics for all the title principals. The problem with this query, though, is that it is very, very, very long. Sequelize can handle that easily, but some other ORMs may complain that this query is way too long and we shouldn't be doing it this way. So how can we improve it? Well, instead of calculating these two conditions inside the SQL query, we can calculate the intersection of those two lists in the application code and then run it again. So let's go back to the application code we have. And this time what we do is we again take principals the way as before, and then we join the two lists of movies in the JavaScript code, and then send the query which has the pre-computed list of movies that we would like to extract. So let's change the application. So let's uncomment this line of code, stop the application, restart it, and then go to the UI part, reload titles. You can see we have the dataset already loaded because the query was very fast. We go to Metis, and now you can see that this thingy executed in 35 milliseconds. So very similar to the first query we executed, and you can see that we have 3 queries, and the last query is trying to get just one title from the database. So what we learned with this example is that Metis can show you when your query is very long and is very inefficient. So we don't need to play by the rules dictated by the ORM that Sequelize wanted us to configure 2 joins between the tables and 2 aliases, but we can implement the stuff and still Metis can show us multiple queries, n+1 queries, and other stuff. So this is what we have in this second example. Let's move on to the third one. So in the third example, what we are going to do is we are going to find a crew of a given movie. So let's run this and let's go back to the database schema showing us what we actually are trying to do. So we want to start with title basics for a particular table. We want to get all the title principals for this title, this movie, and get details of the people worked on this movie. And at the same time, we want to join title crew table. And in title crew, we have a list of directors and writers. So we want to split these lists to get the actual identifiers of people and finally get all the names from name basics. So how can we do that? If we go to the application code, we can see that we can do that with SQL query. So we don't need to define our queries like in the Sequelize ORM itself. We can also provide a particular query written by hand. So what we are doing is we are getting title basics, joining title principals for matching title identifier, and then joining title crew again for a matching title identifier. However, this time it is getting much harder because in order to get people that through title principals, this is rather straightforward. We just get the ncons from name basics and we make sure that it's equal to ncons from title principals. But for title crew, as we saw before, the directors and writers field are denormalized. So they have strings, list of strings stored in their columns. So what we need to do is we basically need to implement a contains operation in the SQL query. So we get the directors field and we examine a couple of scenarios. We first check, okay, if the directors list is actually just one value, then it must be equal to nconst from name basics. But maybe if directors is actually a list of values, so it has more than one value in it, what we need to do is we need to consider three scenarios. Whether the identifier of the person name is at the very end, at the very beginning of the query. So the column starts with identifier, comma, and then whatever. Or this nconst identifier is somewhere in the middle. So there is something at the beginning, then there is comma, then comes the identifier, and then comes comma, and again the rest of the string. Or the identifier is, first scenario, at the very end of this list. So there is something, comma, and finally the identifier and end of string. So we do this for directors, we do this for writers, and we can see that this query will actually get us all the data. Let's see whether it is still executing. You can see we have all the details extracted from the database. Let us now go to Metis and see what happened behind the scenes. So we can go to crew of given movie and we can see that this query executed for nearly 100 seconds. So that was quite a lot. If we go to this query that was executed, we can see our conditions encoded here as expected. The problem with this query is, well, it is reading 12 million rows and scanning this whole table. It is using some indexes later on, but still we need to scan those name basics and they are this is very slow. Can we do somehow better? Because we do multiple OR filters, one of the things that we might try is, instead of using ORs, let's actually use the unions. So what we do instead is we take every single line of this query and we basically replace it with a union part, so a different subquery that we execute and then join all of them together. Let's change our application code to this new query and see whether we can do it this way and whether it's going to work better. So we run this query, we go to the application behind the scenes, we hit reload titles, and let's see what happens now. So let's wait for this query to execute. Okay, so we see the query finished now. Let us go to recent activity in Metis. Let us now open the crew of given movie, and you can see it this time it took it nearly 30 seconds to get results of this query. So you can see that yes, we did select all the data using multiple unions, and it was generally faster even though it read over 130 millions of rows. So generally you can see many table scans in here, many title crew scans, many title principal scans. So generally this query is very big, it runs faster, but is still not fast enough for our case. Can we do better? Yes, we can do better. We can actually rewrite this query in the application code as well. So we first take all the principals for given movie, and we then take all the title crew for a given movie. We take directors and we take writers, we split values for those columns, and then we go to name basics to get the final list of people. So what we do is we split directors, we split writers, and we join these two things together in order to create the names that we wanted to have. So this is how we created this code to query behind the scenes. Let us now change the application to use this third query. So let me restart this application. Let me go to the front-end code. Let me reload titles, and here you can see that the results are now way faster. And if we go to Metis, to recent activity, and refresh the page, you can see that, hey, this time the query executed in like 30 milliseconds. You can see we executed multiple queries again, but this time we got the results much faster. We do not scan this many tables. We scan them very efficiently with indexes. So this is how Metis can help us improve the query. Can we do actually better without rewriting the query in application code? Well, the trick is we can re-implement this query with pure SQL to make it faster, but actually much harder to read. So let us go through this fourth scenario. So what we are going to do is we want to know how many directors we have at most in a given column. And I checked that before this recording this video, and we have something like 1300 directors in a given column. So what we can do is we can generate numbers with recursive CTE to get numbers from 1 until 1500, okay? What we can do next is we get the rows from title crew and we split the directors column by commas. So you can see that we split the director columns by commas, and then we extract a specific value from this list. So we split a comma separated value into basically a list of values, and we get the value which is under a specific index. And we do that for all the indexes from 1 to 1500, which guarantees us that we'll basically extract all the values. We do the same for writers. So we get all the writers, split them, and extract values. Then we join those split associations with title principals table. So what we now have is we have a table like CTE called all associations that has a list of all the names related to a particular movie. So then what we need to do is we basically scan name basics to get all the data. Let us change the application to use this lost query. Let me restart the application. Let's go to the front end. Let's hit reload titles, and you can see we have results available at hand. If we go to recent activity now and go to a crew of given movie, you can see that executed even faster in 28 milliseconds. Although you can see that this query is like much harder to follow, much harder to analyze, and even Metis suggests that, hey, there are some issues with this query. So generally, we can implement that in pure SQL and get even better performance. This is up to you how we do that. But with Metis, we can see what's going on behind the scenes. So in this third example, we learned that we can optimize the query with unions instead of multiple OR statements. That's because unions can execute in parallel. We can rewrite the code, and Metis will show us whether the code that we wrote is doing what we expected. And we can also write much more complex, much more sophisticated query with SQL that Metis is still able to analyze. Finally, in the last example, what we would like to do is we would like to run a query that will find most common coworkers of a person. So we specify a person, and we would like to get a list of like 5 people that a given person worked the most with. So what we do is we go to our application code, and what we are doing is we run a similar query in SQL, query very similar to what we did before. So we take numbers, we split directors, we split writers, we calculate all these associations, and then what we do is when we have a list of all people working with on a particular title, then we can find the transitive list of the people that a person worked with. So we start with a person, we got all the titles that the person worked on, then we get all the lists for all the titles of all the people that worked on these other titles, and finally we calculate the counts of those, we order them by the number of common titles, and we select the 5 rows for that. Let's see what Metis shows for this particular query. So if we go to recent analysis, we can find most common teammates here, and you can see this query executed in nearly 5 seconds. So this is the query that we run. It is pretty sophisticated, it is hard to follow, as we already agreed, reads something like 20 million rows and scans various tables. Could we improve that? Well, if we go to those filters, we can see that we are scanning title crew based on the particular value of the name identifier. We could configure indexes on that and do trigrams, use Postgres extensions to improve that, but generally this is much harder than just using, optimizing this way is much harder because building these indexes takes time, and we don't even have guarantee that the database engine will use that. So let's try rewriting this query in the application code. So what we are going to do is we are taking all the principals for particular person. We are taking all the other principals. So from particular titles, we go to another principals that we have, that we were working on those other titles. And finally, we also do similar dance for title crew for all those other titles. We join those data sets together, and then finally we need to get the data, count the number of titles, and return the five most popular or most common teammates. And this is how we can do that. Let's actually change the application to use this other query. So let me restart the application, and you can see it is now restarted. Let's go to the front end, let's hit reload titles, and let's give it a while to download the data. You can see it finished now. So if we now go to recent activity, you can see that most common teammates executed in nearly 2 seconds. We still have issues. Metis still shows us that, hey, we are scanning title crew. We do not have an index on that, but this time this reads like 10 million rows and is generally faster. So we can see that by rewriting this code to an application code instead of using direct SQL query, we can improve the performance. So this is how you can use Metis to work with your application to see what's going on behind the scenes and see how things are being executed before you actually go to production. The example applications are used are linked in the description of this video, so feel free to experiment on your own. Also, please do check out blog posts we wrote about optimizing queries using Metis, where I explain various of these scenarios and you can see them line by line and understand what is going on. Thank you for watching this video, and I hope Metis can give you much bigger value than what you have now, and then Metis can help you optimize your queries and prevent the bad code from reaching production. Thank you.